Hey guys, welcome to lesson 5.3. Today we're going to talk about solving polynomial equations. Now, what is a polynomial equation, first of all, before we get started? Well, remember, a polynomial is any expression that has multiple terms and different degrees. So one of the cool things about polynomials is that we can solve polynomial equations by using our knowledge of factoring and stuff that we've learned in class before. So we can use our knowledge of factoring to get our factors, and then we can set each of our factors equal to 0, giving us all of our different answers for x. So if we're going to solve polynomial equations, we're going to use these steps down here. First of all, I'm going to write each equation in the form of p of x equals 0. So you're going to set your expression equal to 0. Then you're going to factor p of x using your knowledge of factoring. Last but not least, you're going to use the zero product property to find all of the roots of the expression. Let's go ahead and go down to the first type of example, which is the sum or difference of cubes. So we're going to look at this situation, and I'm first going to give you a formula for factoring the sum or difference of cubes. That way that we can go through and solve using the method of factoring. So if we're taking the sum or the difference of cubes, what that means is you have some term cubed plus another term cubed, or some term cubed minus another term cubed, okay? So if we have the sum of two cubes, what we can say is, well, if I have a cubed plus b cubed, I can really factor that into a plus b times a squared minus ab plus b squared, okay? So an example of this is, what if we had x cubed plus 8? Well, the first thing you must be thinking is, how do I know that this is a sum of cubes? Well, I know that x cubed is obviously some term cubed, and I know that 8 is a perfect cube. And the way that I know that is because if I were to take the cubed root of 8, that would give me 2, because 8 is equal to 2 times 2 times 2. So we could rewrite this expression as x cubed plus 2 cubed. Okay, so we're taking x cubed and adding it to 2 cubed. So a is going to be equal to x, and b is going to equal 2. So now I'm going to take these two terms and I'm going to plug them into this expression above. A plus b times a squared minus ab plus b squared. So we're going to get x plus 2 times x squared minus a times b is 2x plus b squared is 2 squared, or 4. So our answer is going to be x plus 2 times x squared minus 2x plus 4. And that is how we factor a sum of cubes. Now, what about a difference of cubes? So if we have some term cubed minus another term cubed, I could really rewrite that as a minus b times a squared plus ab plus b squared. So notice the differences between the sum of cubes formula and the difference of cubes formula. First of all, for the sum of cubes, we have a plus sign because we're taking the sum, and then the second sign is going to be the opposite of the first, okay? So I'm always going to say this is opposite the first. And then the last term is always going to be positive, so no matter what, when we're factoring sum or difference of cubes, that third sign is going to be positive. Then for the difference of cubes, notice how since we're taking the difference, our first sign is negative, and then our second sign is always opposite the first. So I'm going to write that down once again. The second sign is always going to be opposite the first. So if we're taking the sum, our first sign is plus, our second sign is minus. If we're taking the difference, our first sign is minus, our second sign is plus. Third sign, plus b squared, is always going to be plus. Okay, but this is one of those formulas we're just going to have to get to know. There is a song on the internet. If you look it up on YouTube, it's kind of a catchy song. Not going to sing it to you because this is on a video. If I was in class, I might sing to you. But since we're just watching the video of it, I'm like, no, I don't want you putting my video on the internet. So yeah, just look up the video for the song, and I promise you, you are not going to be disappointed. But if we have x cubed minus 27, well, I know that this is a difference of cubes because x cubed is a cube term, and then 27 is also a perfect cube, because if I were to take the cubed root of 27, that would give me 3, because 27 is equal to 3 times 3 times 3. So a is going to equal x, and b is going to equal 3, giving us x cubed minus 3 cubed. So if I plug that into the formula, I'm going to have a minus b, or x minus 3, times a squared plus ab plus b squared. So x squared plus 3 times x plus b squared. B squared is 3 squared, which is 9. So this is going to be the final factored form for the difference of cubes. All right, so now we're going to talk about some techniques just in general of factoring. So the first technique that we are going to use when we are solving polynomial equations is we are going to factor by using the GCF. This is always the first thing you want to do when you're factoring. You want to look and see, do I have a GCF? And if so, I'm going to pull it out. So this is in simplest form. So we're going to factor out the greatest common factor from all terms. Well, first of all, let's go ahead and take a look at our terms. Our numbers are 18, negative 27, and positive 45. Something that goes into all three of those numbers is a 9. And since that's the greatest number that comes out of all of those, the GCF is going to be 9. But now I have to look at my variables. I have x to the fourth, x to the third, and x squared. Since the smallest exponent here is 2, that's going to be the biggest thing I can pull out of all three of them. As obviously, I can't pull out any degree higher than 2. Otherwise, this thing won't be able to work. So my GCF is going to be 9x to the second power. So if I pull a 9x squared out of each of these terms, 18 divided by 9 is 2. X to the fourth divided by x squared, or we're just going to subtract those exponents. 4 minus 2 is 2x squared. Now, if we pull a 9x squared out of 27, well, 27 divided by 9, since my sign is negative, that gives me negative 3. X cubed divided by x squared, 3 minus 2 is 1, so we have x to the first. Last but not least, 45 divided by 9 is going to be plus 5, and then x squared divided by x squared is just 1, giving us 9x squared times 2x squared minus 3x plus 5. All right. Now, the second thing we can do when we're factoring is we can use quadratic trinomials, or in other words, we can use the factor diamond. So if we have ax squared plus bx plus c, we can find the factors with the product a times c and the sum of b. So let's go ahead and use our factor diamond here because we have 6x squared minus 5x minus 4. Well, I know that the top of the diamond is going to be a times c, or 6 times negative 4. That's going to give me negative 24 on the top, a times c. And on the bottom, I'm going to put b, or negative 5. So factors of negative 24 that add up to negative 5, well, I know that 8 and negative 3, or, that wouldn't work because that would give me a sum of positive 5. But if I have negative 8 and positive 3, if I multiply those, I get negative 24. And if I add those, I get negative 5. So my two factors are going to be negative 8 and positive 3. Since my leading coefficient is greater than 1, I'm going to drop that down using a fraction. So I have 1 over 6, and then inside my binomials, I'm going to have 6x because my leading coefficient is not 1. My two factors are going to be negative 8 and positive 3, so let's drag and drop those in. I have 6x minus 8 times 6x plus 3. And obviously, I need to simplify this a little bit. Now, at first glance, this might be a little tricky because if I distribute this 1/6 into any two of those, I'm going to have fractions left over. But one of the things that I can do is I can pull some stuff out of either of these binomials. Let's go ahead and look at the second binomial. I have 6x plus 3. There is something in common with 6 and 3. I can pull out a 3 here. So really, this is going to turn into 1 over 6 times 3, because I'm going to pull a 3 out. And I'm going to have 6x minus 8 times, if I pull a 3 out of the second one, 6 divided by 3 is 2, so 2x. 3 divided by 3 is 1, so I have 1 over 6 times 3 times 6x minus 8 times 2x plus 1. Well, I know that 1/6 times 3, I have a 3 on top and a 6 on the bottom. So 6 divided by 3 gives me 2. That turns into 1/2. So now, I'm going to write this over here. I am going to have 1/2 times 6x minus 8 times 2x plus 1. Okay? And I can distribute this 1/2 into both terms in the first binomial. So if I distribute 1/2 times 6x, that's going to give me 3x. 1/2 times negative 8 is going to give me negative 4. So I have 3x minus 4 times 2x plus 1. And this is going to be final factored form for this expression. So obviously a little bit more involved, but the general principle remains the same. We're using the factor diamond, and then we are finding factors of a times c. They give us a sum of b. All right, let's go down to perfect square trinomials. So we know how to factor perfect square trinomials using these two formulas. We talked about this in a previous lesson. Now, the way you know you're looking at a perfect square trinomial is if you have something squared on both ends. So on this case, this would be x squared on the left-hand side, and in this case, this would be 8 squared on the right-hand side. So two things that are squared on the end, and then the middle is going to be the product of both of these things, the square root taken of them. So if I take the square root of x squared, I just get x. If I take the square root of 64, I get 8. So the middle is going to be 2 times a times b, or 2 times 8 times x. In other words, 16x. So if it follows that general pattern, then you say, hey, this is a perfect square trinomial. Now, another way you could do this is just by using the normal method of factoring, or the factor diamond. So I'm going to use the factor diamond just to show you. We have a times c is 1 times 64, and b is 16, factors of 64 that add up to 16. Well, I know that 8 times 8 gives me 64. 8 plus 8 gives me 16. So this is really x plus 8 times x plus 8, or x plus 8 squared. So that's going to be a perfect square trinomial. Then if we look at the second one, x squared minus 16x plus 64, well, if I use my factor diamond here as well, a times c is going to be positive 64, b is going to be negative 16. So once again, factors of 64 that add up to negative 16. Well, if I have negative 8 times negative 8, that's going to give me 64. Add those, I get negative 16. So this is going to be x minus 8 squared. Okay, and that follows the formula because obviously perfect squares on the end, the middle is the product of 2 times a times b with a minus sign. So that's the difference. Go ahead and make sure you recognize those formulas and those possibilities, but keep in mind that you can always revert back to the factor diamond for the perfect square trinomials. All right, next page. Now we have the difference of squares. So what if we have a binomial and then both of these are perfect squares? Well, in this case, it's not both perfect squares, but I'm going to show you how to use it when it's not a perfect square either. So difference of squares tells us that if we have a squared minus b squared, that is equal to a plus b times a minus b. So two terms, both of them are perfect squares. We can break them up using the formula. Now, the way that I'm going to have you set this up is if we know that a squared is going to equal 4x squared, and b squared equals 3, because we have 4x squared minus 3, then to find a and b, to plug it into the formula, I'm going to take the square root of both of those. So the square root of 4x squared is going to give me 2x. The square root of 3 is just going to be the square root of 3. So really, I have a equals 2x and b equals the square root of 3. Now, we know that if we were to plug this into the formula, a plus b times a minus b, this would look like 2x plus the square root of 3 times 2x minus the square root of 3. And if I were to refoil this, here's what would happen. 2x times 2x is 4x squared. 2x times negative square root of 3. 2x times positive square root of 3, well, that would be a positive and a negative, which would turn into 0. And then the square root of 3 times negative square root of 3 is just negative 3, giving us 4x squared minus 3. So we can use the difference of squares if we have a binomial and our first term has an x squared in it. Then we can set it up using the difference of squares. Okay, the next method is going to be factor by grouping. So how do you know to use the factor by grouping method? Well, you know if you have 4 terms, this is probably going to be something that you're going to use factor by grouping with, okay? So 4 terms, woo, look at this. You're going to be using factor by grouping. Now, here's how we're going to use factor by grouping. First of all, the first step is we are going to group the first 2 terms, and then we're going to group the last 2 terms. So in other words, what I'm doing here is I'm going to split this down the middle, so I have a left-hand side and a right-hand side. I group the first 2 terms, and then I group the next 2 terms. Okay, and then the next thing you're going to do is you are going to factor out a GCF from both groups. So if we factor out a GCF from both groups, let's look at that first group, x cubed minus 4x squared. If I want to factor out a GCF, well, I know that both of these have x squared in common. So if I was to pull an x squared out, I would have x cubed divided by x squared is x to the first. Negative 4x squared divided by x squared is negative 4. Then if I factor out a GCF from the second side, I have negative 9x plus 36. Well, I know that both of those terms, negative 9 and 36, have a 9 in common. Since my first term is negative, I'm going to pull out a negative as well. So that's going to be negative 9 I'm pulling out of here. And then what's left over is negative 9x divided by negative 9 is positive x. 36 divided by negative 9 is going to be negative 4. Now, what you are looking for is you want these two binomials to be exactly the same, all right? So I'm going to say, hey, make sure binomials should be the same. And if they are the same, that means you did it correctly. If they're not the same, it either means you didn't do it correctly or this is not able to be factored by grouping. And I'm going to show you why this is important in a second, because after we factor out a GCF from both groups, then we are going to factor out the common binomial. And I'm going to call that the common binomial. I'm going to highlight that because the common binomial is going to be the binomial that you see on both sides of the grouping. Okay? And we're going to factor that out. So if I were to factor out an x minus 4, here's what would happen. I would have x minus 4. And then if I factor an x minus 4 out of this first term, I would be left with x squared. And then if I factored out an x minus 4 from the second term, I would just be left with negative 9. So I have my binomial as my first factor because I factored it out. And then the leftover stuff for my second factor, x squared minus 9. Now, here's the problem. I can still factor x squared minus 9, can I not? So the very last thing you're going to do with the process is you are going to factor farther if necessary. And it might not always be necessary, but sometimes it is going to be necessary to factor farther. So notice how, oh my goodness, I can factor x squared minus 9. That follows the difference of squares format because we have x squared minus 9. It's a binomial, and both of these are perfect squares. So if a is equal to x squared, or excuse me, if a squared is equal to x squared, and if b squared is equal to 9, well then a must equal x and b must equal 3, because the square root of x squared is x, square root of 9 is 3. So now I can factor this using the a plus b times a minus b. So my final answer is going to be x minus 4 on the outside, and then I have x plus 3 times x minus 3. And I'm actually going to move this all over because I was not giving myself enough room. Okay, so that's going to turn into x minus 4 times x plus 3, x minus 3. Okay, so this one was kind of a combo. We use factor by grouping first, and then at the very end, we're going to have to use difference of squares. And I'm going to actually star that and put that here just so you know. That is a difference of squares. Okay. So let's go over one more type before we just get into it and talk about how to solve these things. So the last type of factoring you're going to need to know is the sum or difference of cubes. And once again, we know that the sum of cubes, a cubed plus b cubed, factors into a plus b times a squared minus ab plus b squared. First sign is positive, second sign is negative, third one is always positive. And then a cubed minus b cubed, that factors into a minus b times a squared plus ab plus b squared. First sign is negative, second sign is positive, third sign is always positive. Okay, so if we have 64x cubed plus 1, well, first of all, since this looks like a sum or difference of cubes, I'm going to say a cubed equals 64x cubed, and b cubed equals 1. So then a is going to be the cubed root of that. Well, if I take the cubed root of 64, that's going to give me 4. The cubed root of x cubed is just x. And then if I take the cubed root of b cubed, b is going to equal 1. So I'm going to plug a and b into the sum of cubes formula. So I'm going to have a plus b, or 4x plus 1, times a squared, which is 4x squared, or 16x squared, minus AB. Minus AB here is going to be minus 4 times x, because 4x times 1 is going to be just 4x, plus b squared. B squared is plus 1. So that is the factored form of my sum of cubes. Figure out what a and b are, plug them into the formula. Then I have the difference of cubes, 64x cubed minus 1. Well, if I know that a cubed is equal to 64x cubed and b cubed is equal to 1, then just like before, a must equal 4x and b must equal 1. So I'm going to plug that into the difference of cubes formula as I am taking the difference. So this is going to be a minus b, or 4x minus 1, times a squared, which is 16x squared, plus ab, so in this case, plus 4x times 1, plus b squared, or plus 1. So the answer is 4x minus 1 times 16x squared plus 4x plus 1. Okay, so be very careful with your signs here. Remember, if we're taking the sum of cubes, the first sign is positive, second sign is negative. If we're taking the difference of cubes, that's going to be first sign is negative, second sign is positive. All right. Now let's get into some actual examples of solving these polynomials. So what are the real or imaginary solutions to each equation? Well, we have x squared minus 1 times x squared plus 4 is all equal to 0. So what I'm going to do here is, first of all, I recognize that this is already in factored form, so I don't have to factor it again because it's already there. I could factor this x squared minus 1 down farther, and so let me go ahead and show you what that would look like. So since this is technically a difference of squares, I can say, well, I know that a squared is equal to x squared, and b squared is equal to 1, so a must be equal to x, and b must be equal to 1. I know that the difference of squares formula is a plus b times a minus b. So I can say x plus 1 times x minus 1 times x squared plus 4 equals 0. So I just expanded x squared minus 1 into its factors. Now that I'm in factored form, I can set both of those, all three of those actually, equal to 0, as that's the zero product property. Set all of your factors equal to 0. So I have three scenarios: x plus 1 equals 0, x minus 1 equals 0, and x squared plus 4 equals 0. We're going to solve for x in each case. First case, x is equal to negative 1. Second case, x is equal to positive 1. Third case, we're going to subtract 4 from both sides. We get x squared equals negative 4. Oh, then we got to take the square root to get x by itself. And we know that we're going to have an imaginary solution here. X is equal to square root of negative 4. Well, I know that that can break up into the square root of negative 1 times the square root of 4. So I know that the square root of negative 1 is equal to plus or minus I. The square root of 4 is plus or minus 2. So x is going to equal plus or minus 2 times I. So I have x equals negative 1, x equals positive 1, x equals positive and negative 2i. So if I were to write all of these answers, I would say x equals positive 1, negative 1, positive 2i, and negative 2i. So factor it down as far as you can, then use the zero product property to set each of your factors equal to 0. All right, number 5, we have x to the 5th plus 4x cubed is equal to 5x to the 4th minus 2x cubed. So if I'm going to factor this, I'm going to erase that a little bit. If I'm going to factor this down, the first thing I got to do is I got to get all of my terms on the same side because I cannot factor unless I have p of x is equal to 0. So let's go ahead and move all of our stuff over. So I'm going to go ahead and subtract 5x to the 4th from both sides. That's going to be somewhere right about here. And then I'm going to also add 2x cubed to both sides. So let me actually move this over a little bit. And I'm going to add 2x cubed to both sides. And so we're going to be left with now x to the 5th minus 5x to the 4th. 4x cubed plus 2x cubed is going to be plus 6x cubed. And that is all equal to 0. Hallelujah, it's equal to 0. That means that we are good to move on to the next step, which is to factor. So let's look at all the factoring methods we have. Well, first of all, I'm always going to check and see if I have a GCF. Since all of these have x's, I know that I can pull some degree of x out. My lowest degree of x is x cubed, so I'm going to pull an x cubed out of each of those. X to the 5th divided by x cubed is x squared. Negative 5x to the 4th, that's going to be negative 5x squared. or actually no, negative 5x because I'm pulling out x cubed. And then 6x cubed divided by x cubed is plus 6, and that equals 0. Now, I am not done factoring yet. I always have to get this in the most factored form before I can set all of my factors equal to 0. Let's use our factor diamond here to figure out what that's going to be in factored form. So, x squared minus 5x plus 6. A times c is 1 times 6. B is negative 5. Factors of 6 that add up to negative 5, negative 2, and negative 3. So this is going to turn into x cubed, and then x squared minus 5x plus 6 factors down farther into x minus 2 times x minus 3, and that is equal to 0. All right, so since I can't do anything else to this, I have all of my factors equal to 0. I can use the zero product property to set each of these factors individually equal to 0. So I say x cubed equals 0, x minus 2 equals 0, x minus 3 equals 0. I'm going to solve for this in each case. First case, take the cubed root of both sides, and then I get x equals 0. Second case, add 2 to both sides, x equals 2. Third case, add 3 to both sides, x equals 3. So my three answers are x equals 0, x equals 2, and x equals 3. All right, let's move on to the next page. Next page, so we have find the real or imaginary solutions for each polynomial equation. Now, any old person off the street would come in here and say, hey, I have x to the fourth equals 16. So that must mean, oh, I'm going to take the fourth root of both sides, and then I'm going to find my answer. Wah, wah, wah. No, you're not going to do that. And the reason is, if you were to jump straight into taking the fourth root of things, you would miss possible solutions. So we're going to go ahead and use our factoring techniques to find the answers, okay? Because if we were to take the fourth root right now, that would only give us our real solutions, but we also want to find our imaginary ones. So the first thing we're going to do is we're always going to move our stuff to one side. I want to set this equal to 0. So I'm going to have x to the fourth minus 16 equals 0. And once I have this set equal to 0, I can use one of my factoring techniques to factor this out. Now, this looks very closely similar to a difference of squares because I have an even power, and then I have two terms that are being squared right here. So I'm going to use the difference of squares. I know that a squared equals x to the fourth, and b squared equals 16. So if I take the square root of both sides, a is going to equal, well, the square root of x to the fourth is x times x times x times x. So if I take the square root of that, I have two pairs of x's, which is going to give me x squared. Then the square root of b squared is going to be b equals square root of 16 is 4. So that's going to factor down into x squared plus 4 times x squared minus 4, because again, we're using a squared minus b squared equals a plus b times a minus b, putting that in factored form. And that is still equal to 0. But here's the deal. Can we factor this down any farther? And I think, yes, we absolutely can factor this down farther, as if you take a close look at x squared minus 4, that still follows a difference of squares situation. So here, I'm going to say a squared equals x squared, b squared equals 4. If I take the square root, a is going to equal x. Take the square root, b is going to equal 2. This is going to turn into x squared plus 4 times x plus 2 times x minus 2, all equals 0. Okay, so this is a situation where we have several instances of difference of squares. Now, can I factor this down farther? Absolutely not, because we don't have a sum of square formula. We just have a difference of square formula. So now, since this is in factored form, I'm going to use the zero product property to set all of those equal to 0. So x squared plus 4 equals 0. X plus 2 equals 0. X minus 2 equals 0. So for my first situation, I subtract 4, I get x squared equals negative 4. Then if we take the square root of both sides, x is going to equal, the square root of 4 is 2, so I have plus or minus 2, and then the square root of negative 1 is I. So that's going to be positive or negative 2i for the first answer. Then for the second answer, x plus 2 equals 0, well, that means x is going to equal 2. Second one, or excuse me, that's a negative 2, my bad. X minus 2 equals 0, that's going to give us positive 2. So these are all of my answers. I have 4 different answers, plus or minus 2i, negative 2, and positive 2. All right, part B, we have x cubed equals 8x minus 2x squared. Well, first of all, I got to go to all those terms on the same side. So I'm going to have to use my knowledge of inverse operations and get all that stuff to the other side. So let's subtract 8x from both sides. And then I'm also going to add 2x squared to both sides. I want all of my terms on the same side. So this is going to give me x cubed plus 2x squared minus 8x is equal to 0. Now the next thing we can do is we can factor out a GCF because all 3 of these terms have something in common, and it is an x value. So I'm going to pull an x out of this because my lowest degree is 1. So if I say x times x cubed divided by x is x squared, 2x squared divided by x is plus 2x, negative 8x divided by x is negative 8, and that is equal to 0. Now let's go ahead and use our knowledge of factoring to factor this down farther, because I know that x squared plus 2x minus 8 can be factored down farther. So if I put a times c on top, 1 times negative 8 is negative 8, b is going to be 2. Factors of negative 8 that add up to 2, well, I know that 4 times negative 2 is going to give me negative 8. 4 minus 2 gives me positive 2, so I have 4 and negative 2 as my factors. This turns into x times x plus 4 times x minus 2, all equal 0. Now, since this is in factored form, I use the zero product property, and I say all of my factors are equal to 0, so x equals 0, x plus 4 equals 0, x minus 2 equals 0. So I'm going to solve for each of these. Obviously, the first one is still x equals 0. Second one is going to be x equals negative 4. Third one is going to be x equals positive 2. So my 3 answers are 0, negative 4, and 2. All right. Let's go ahead and move down to part C. We have x times x squared plus 8 is equal to 8 times x plus 1. Well, obviously, I kind of want to get this into some form where I can get all of my terms on the same side because I don't want this equal to something. I want this equal to 0. So in order to do this, since I have parentheses, I'm going to have to take care of those because otherwise it's going to be real hard to combine like terms with those parentheses around. So let's get rid of those. We're going to distribute x into both terms in the first one. So we have x times x squared is x cubed. X times 8 is plus 8x. And that's equal to 8 times x and 8 times 1. So that's going to be 8 times x is 8x. 8 times 1 is plus 8. Now I'm going to move all of my stuff to the other side. Okay, so let's go ahead and subtract some stuff. So I'm going to subtract 8x from both sides. And I'm also going to subtract 8 from both sides. So that's going to turn into, obviously it looks a little crazy over here, but that turns into 0 on the right. And this is going to turn into x cubed plus, oh, would you look at that? My 8x's cancel. Hallelujah. That makes my life pretty easy. 8x's go away. So I have x cubed minus 8 is equal to 0. Now, what on earth does this look like? This looks like a difference of cubes, if you ask me, because I have x cubed minus 8. I know that if I say, okay, well, a cubed is equal to x cubed, b cubed is equal to 8, well, then I know a is going to equal x, and then the cubed root of 8 is going to give me b equals 2. So I'm going to plug that into the difference of squares, difference of cubes formula. Let me just write that down to refresh your memory. If we have a difference of cubes, that's going to be a minus b times a squared plus ab plus b squared. Okay, so let's go ahead and break that up and put that into factored form. So factored form here is going to be, I have x minus 2, or a minus b, times a squared, or x squared, plus a times b, which is plus 2 times x, plus b squared, which is 2 squared, or 4. And that is equal to 0. Now, here's the problem. This may appear that it can be factored down farther because it's a trinomial. But if we were to create a factor diamond, we would have 4 on the top, 2 on the bottom, factors of 4 that add up to 2. I can't think of any. So let's think of another method that we can use to solve a trinomial without factoring. Oh, would you remember that? The difference? Oh my goodness. If we have this trinomial, we can use the quadratic formula to find our values of x. Or in other words, x equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay, we can use that to find the x values that come from this trinomial. So first of all, I'm going to say that x minus 2 equals 0, x squared plus 2x plus 4 equals 0. I can obviously see that x equals 2 is going to be my first answer, but then my second answer, I'm going to use the quadratic formula. So I'm going to say, let me put this in purple, x equals negative b, or negative 2, plus or minus the square root of b squared, which is 4, minus 4 times a times c, all over 2 times a, or 2 times 1, which is 2. If I simplify that, let's do the inside of that square root. 4 minus 4 times 1 times 4. Well, that's really going to be 4 minus 4 times 4, or 4 minus 16. 4 minus 16 gives me negative 12. So I have negative 2 plus or minus the square root of negative 12 over 2. Well, if I take the square root of negative 12, obviously I know that's the square root of negative 1 times the square root of 12. The square root of 12, we can pull some stuff out of. I can pull a 4 and a 3, and then a 2 and a 2. So I have a pair of 2s and a 3 left over. So this is going to turn into negative 2 plus or minus, that's going to be 2i, square root of what's left over, which is 3, all over 2. Obviously, all three of these terms are all divisible by 2. So if I pull a 2 out of each of those, I'm just going to be left with x equals, let me go ahead and write this down here, x equals, well, all those are going to go away, so I have negative 1 plus or minus I square root of 3. Okay, so those are going to be my roots. Now my roots, if I were to write this just kind of in a different form, I would say roots are going to be the set that includes, I cannot draw that symbol for the life of me. I'm telling you, I have to practice this so much. It's so embarrassing. Oh, that looks pretty good. Okay, so we're going to have 2, and then negative 1 plus I square root 3, and then negative 1 minus I square root 3. That is the set of all of my answers. Okay? Now, obviously, this one was a little bit more involved because we had a difference of cubes, and then we also had to use the quadratic formula to factor out that trinomial, okay? But that is how you solve the more complicated ones. All right, example number 3. Now we're going to learn how to use the graphing calculator to give us the roots of some equation. So let's go ahead and look at example number 3. We're going to use 2 different methods to solve this problem. X cubed plus x squared equals x minus 1. The first way that you can use your graphing calculator is by using the intersect feature. So this is the first method. Now, since we have something on the left-hand side of the equal sign and something on the right-hand side, we're going to create 2 separate equations on our graphing calculator. Y equals x cubed plus x squared, and y equals x minus 1. So on your graphing calculator, you're going to click on y equals. Then you're going to type in those 2 expressions. So we have x cubed plus x squared. And then for the second equation, we have x minus 1. So we give each of the side of the equal sign its own equation on the graphing calculator. Then we click on graph. Now, once this graphs, you're going to notice that we have 2 separate graphs, and they are going to intersect each other. So what we're looking for to find the roots is we're looking for this point of intersection. So in order to find the point of intersection, we click on second trace and go down to number 5, intersect. Click enter. Now, this is asking you, is this the first curve? Well, go ahead and get close to that point of intersection and then click enter. Then it's asking, is this the second curve? Well, it's blinking on the red line now, so it's close to the point of intersection. I'm going to click enter. For guess, we just click enter again. And then the point of intersection is right here, negative 1.8393 and negative 2.8393. So I'm going to go ahead and write down that point of intersection right here. So this right here is the point, negative 1.8393, comma, negative 2.8393. Now, what we're looking for, if we're looking for the root, is we're looking specifically for the x value, okay? Because that's essentially what we're solving for is x. So I'm going to say that x is approximately negative 1.8393. And that's the answer to this question, finding the roots. All right, now the second example, or the second method, is going to be the zero feature. So this is just another method for finding the same exact thing. So I'm going to clear everything off of my calculator real quick. I'm going to show you how to do the next method. So another method that we can use is the zero feature. Now, if we're going to use this feature, what we're going to do is we're going to rewrite the equation first so that we set it equal to 0. So I'm going to essentially move all of my stuff to one side. So let's go ahead and subtract x from both sides. And we're also going to add 1 to both sides. So now, on that right-hand side, everything's going to cancel. And on the left-hand side, I'm going to have x cubed plus x squared minus x plus 1, and that is equal to 0. So now I'm going to type that new equation into my calculator. I have x cubed plus x squared minus x plus 1. Now I'm going to click on graph. Now if I take a look at my graph here, I notice that this is one graph now instead. And since we're looking for the roots of this function, we're essentially looking for where that graph crosses the x-axis. So I'm going to click on second trace, and this time I'm going to go down to number 2, 0. Then I click enter. Now I'm going to get close to that point, and notice how the question is left bound. So I'm going to go to the left of that intercept and click enter. Then I'm going to go right bound, so I'm going to go above that point of intersection with the x-axis, click enter. And then for guess, just click on enter again. And notice how it gives you the 0 of that function, which means x is approximately negative 1.8393. Okay? So it's the same exact answer, just two different methods to find it. All right, next page. So now we have three consecutive integers whose product is 480 more than their sum. We are going to use the methods that we have learned today to model a problem situation. So obviously, I'm talking about three consecutive integers here, so I'm going to have to define those integers using variables. I know that the product of those integers is 480 more than the sum of the integers. Let's go ahead and define our variables first. So I'm always going to define an x, and I'm going to say that x here is just some random integer. Okay? And then if I'm talking about consecutive integers, remember consecutive means one after the next. So the next integer is going to have to be x plus 1. And that's going to be the next integer. And then the third integer is going to have to be x plus 2. Because consecutive integers mean one after the next, so we're adding 1 each time to get to the next consecutive integer. Now the product of these integers is 480 more than the sum. Well, if I'm going to represent the product, that's going to be x times x plus 1 times x plus 2. And that is equal to 480 more than the sum. Well, the sum of the integers is just going to be x plus 1 plus x plus 2. And 480 more than that means we're going to add 480. All right, so obviously in order to do this problem, I have to simplify this a little bit. I'm going to go ahead and use FOIL to take care of these two binomials multiplied by each other. So I'm going to multiply x times x first. X is still on the outside here. X times x gives me x squared. Then I have x times 2 plus x times 1. That's going to be plus 3x. And then 1 times 2 is going to give me plus 2. And that is equal to the sum of x plus 1, x plus 2, and 480. All right, now I'm going to distribute this x into all three terms. So then that side is taken care of. X times x squared is x cubed. X times 3x is plus 3x squared. X times 2 is plus 2x. And that is equal to, well, let's go ahead and combine some like terms here. X plus x gives me 3x. And then I have 1 plus 2 plus 480. That gives me plus 483. Now, in order to solve the problem, I'm going to have to move all of my terms to that left-hand side. So let's go ahead and subtract 3x from both sides. And then I'm also going to subtract 483 from both sides. So now I'm left with x cubed plus 3x squared. 2x minus 3x is negative x minus 483, and that equals 0. Okay, so I'm going to go ahead and use my calculator to solve this using the 0 feature. Now, if I use the 0 feature on my calculator, I'm going to say by graphing, okay? So if I use the graphing calculator, that method that we just explored before, that would give us an answer of 7. So we would find that this graph would cross the x-axis at 7. So that means, since we're talking about 3 consecutive integers, our 3 answers would be 7, 8, and 9. Okay, so we're going to use our graphing calculator to figure out what the 0 is by plugging this in. And then we're going to go to second trace, click on number 2, the 0 feature. And then from there, we're going to find the 0 on our graph, and that would give us 7. And since we know that we're talking about 3 consecutive integers, 7, 8, and 9 would be the 3 consecutive integers. All right, last example today. So the Perez twins were born 2 years after their older sister. This year, the product of the 3 siblings' ages is exactly 4,558 more than the sum of their ages. How old are the twins? So we're going to go ahead and label a couple things here. First of all, I'm going to say that x is equal to the twins' age. Okay, because we're looking for the twins' age, that's the unknown. And we know that they were born exactly 2 years after their older sister. So their older sister's age is going to have to be x plus 2. So now that I've defined my variables, I'm going to go ahead and set up an equation that represents the scenario. So this year, the product of the 3 siblings' ages is exactly 4,558 more than the sum of their ages. Now, if I'm taking the product of their ages, well, I know that they're twins, so they have the same age. So I'm going to have child 1 is x. Child 2 is the twin, so I'm multiplying it by x again because the twins have the same age. And then I'm multiplying that by the older sister's age, which is x plus 2. That's the product of all 3 children's ages. And that is equal to the sum of all of their ages plus 4,558. So that's equal to x plus 2 plus 4,558. Okay. So now I'm going to do some multiplication here. So on the left-hand side, x times x gives me x squared times x plus 2. And that is equal to, let's go ahead and clean some things up here. X plus x plus x, that gives me 3x. And then I have 2 plus 4,558. That's going to be plus 4,560. Okay, let's go ahead and distribute. On that left-hand side, x squared times x gives me x cubed. X squared times 2 gives me plus 2x squared. And that is equal to 3x plus 4,560. Now I'm going to subtract those off to the other side. And then once I subtract those off, I have something that I could easily plug into my calculator and figure out what the 0 is. So I have x cubed plus 2x squared minus 3x minus 4,560 equals 0. Now, if I plug that into my calculator, here's what's going to happen. I have a graph here, and I know you guys can't see this, but what's happening in general here is that this graph is crossing the x-axis right here at 16, 0. So if you were to plug this into your calculator and then use the 0 feature to find the x-intercept, you would find an x-intercept at 16, 0. So what this is telling you is that x is equal to 16, which means that the twins are 16 years old. And that is the answer to the problem. Okay, so we're using the math that we know to set up situations and figure out real-world scenarios. All right, guys, that's the end of the lesson for today. Go ahead and do your homework, and I will see you back here next time. Thank you.